I'm Tony, your maths tutor. In this lesson, we shall look at a couple of questions that you are likely to come across when sitting for O-level external examinations. We consider a couple of questions, and the first one goes this way. Solve. It's an inequality. 7 into bracket x plus 4, close the bracket, minus 2 over 3, open the bracket, x minus 6, close the bracket. Then you have less than or equal to 2, open the bracket, x minus 3 into another bracket, x plus 5, and close both brackets. Now, whenever you hear solve, you would always meet a variable in either an equation. Of course, it's always an equation or an inequality. Whenever they use the word solve, you either have an equation or an inequality. In this case, we have an inequality. Now, when they ask you to solve, what they're asking you to do is to find the unknown in the equation or the inequality, as the case may be. In this case, we have an inequality. So we need to find the unknown in this inequality, which is x. Now, how do we do this? We would try to simplify this problem as much as possible. That is, get rid of all the brackets so that you can collect all your like terms, that is all the terms involving x, and all the constant terms. When I say constant terms, I mean numbers, plain numbers without a variable. So we go ahead and do this. We expand the brackets. How do we expand this bracket? There is a plus sign in front of 7. Whenever you have a number, say 3, without a sign in front of it, there is an invisible positive sign, plus 3, okay? So this is plus 7 here. In order to open this bracket, what we need to do is multiply plus 7 outside with every term inside the bracket. When I say term, this is what I mean. This is one term, this is another term of the expression in the bracket. Okay? Expressions are without equal to sign or inequality, because this does not involve an equal to sign or an inequality. It is an expression. This is an expression. This is an expression. But everything considered together is an inequality. If this were equal to, it becomes an equation. So that's the difference between an equation and an expression. An expression does not involve equal to sign or an inequality. So we will use the term outside to multiply every term inside the bracket. Plus 7 times plus x, like I stated earlier, when there is no sign here, it means it's positive. Plus 7 times plus x will give you plus 7x. In fact, 7 times x is 7x. 7x means x in 7 places. 7 times x. Okay, 7 times x. We proceed again. Plus 4 times plus 4. That's plus 28. Plus 28. We do the same thing here. Minus. Now, there is a plus sign here. The sign in front of the term outside the bracket is negative, so that we have minus 2 over 3 times plus x. Minus times plus, let's remember this. Minus times plus is minus. So also, if you turn it around, plus times minus, it gives you minus. Plus times plus is plus, and minus times minus is plus as well. What do you notice? When the signs are different, in fact, let's do this. You would notice that when the signs are, when you are multiplying different signs, you will always get a negative value. The same thing happens here. Different signs, you are multiplying them, you get a negative value. But when the signs are the same, plus and plus, you have a plus. Minus and minus, you have a plus still. So when the signs are the same, you get a positive value. When the signs are different, you get a negative value. Here we see that this is minus, this is plus. You should get a negative value. So we have minus 2 over 3 x. Remember, when opening a bracket, you use the term outside the bracket to multiply all the terms in the bracket. That's the procedure for opening a bracket. Again, we have to multiply this term. Minus 2 over 3 times minus 6. Minus times minus will give us what? Plus. The signs are the same. So when you multiply them, you should always get a positive value. Now, 2 over 3 times 6. Let's see what it gives us. 6 can be expressed as 6 over 1. 3 here 1, 3 here 2. So that we have 2 times 2, 4. Divided by 1 times 1, which is 1. And 4 over 1 is 4. So the multiplication of those two terms would give us 4. Less than or equal to. Let's open the other side of the inequality, the right-hand side. Just like we did for all the other brackets, we do the same thing for this bracket as well. First, let's open this bracket. We have 2 into bracket x. Remember, there is a plus sign here. So minus times plus would give us minus, and 3 times x would give us 3x. Again, minus times plus will give us minus, and 3 times 5 would give us 15. Remember, there is still a bracket. Don't throw away brackets. You must open them with this procedure. Don't just throw away brackets. You must follow this procedure. Multiply the term outside by all the terms inside. We keep going. 7x plus 28 minus 2 over 3x plus 4. Now we need to open this bracket as well. Less than or equal to. There is a plus sign in front of 2. Plus times plus here is plus. 2 times x, 2x. We move to the next term. Plus times minus, minus. 2 times 3x. Remember what 3x means. 3x means 3 times x. Okay? 3x means 3 times x. Now, you are doing 2 times 3x, which means 2 times 3 times x. Of course, we know 2 times 3 will give 6 times x. And of course, this would give us 6x. It's just notational. We usually throw away the product sign and we write it this way in short form. But it simply means 6 times x. And we pronounce it 6x. So this would give 6x. And finally, plus times minus would give minus. 2 times 15 would give 30. 30. So we have succeeded in opening all the brackets. What we are going to do next is to collect all those terms that look alike. All the terms that look alike. What do I mean by look alike? All the terms that have the unknown, the variable. The unknowns are called variables. All the terms that contain the variable x are collected together, while all the numbers, which we call constants, are collected together. We do not ignore the signs in front of these terms, as you would see in what we are going to do just now. So our goal now is to collect all the like terms together. Collect like terms. Now, what are the like terms? We have 7x here, not just 7x, plus 7x. There is a plus sign in front of 7x, plus 7x. Here, we have 2 over 3x. There's the variable here. So we have to bring it to 7x. But remember, the sign in front of this belongs to it. The sign in front of this term belongs to it. And what's that sign? It is the negative sign. So we call it collectively as minus 2 over 3x. That's another like term to 7x. Let's move to this other side. We have 2x here. we have the variable x. So it's a like term to 7x and minus 2 over 3x. We also have the term 6x, not just 6x, but minus 6x, because this sign belongs to it. So minus 6x. So these are all like terms. We will try to bring them together. And then the numbers are also like terms. We try to collect them together. What we will do is we will try to bring all the terms with the variable x to the left side of the inequality and push all the constant terms to the right side of the inequality. So we proceed. We have 7x minus 2 over 3x. Now, 2x is on a different side of the inequality. To bring it here to join the other like terms, we have to consider some things. We don't just bring it and say 2x. No. To bring it here, it means we have to do something to both sides of the inequality. Because this is positive, what would help us get rid of 2x here is by subtracting 2x from this side of the inequality. That is, 2x minus 2x would give 0, right? Now, if we do it here and we don't do it here, we have disturbed the value. So if we do it here, we must also do it. It's like looking into a mirror. Okay? If you are sitting outside of the mirror and you are looking into a mirror and you are bobbing your hair outside of the mirror, is it possible for you to not be bobbing your hair in the mirror? It's not possible. That's the way this works. If you decide to bob your hair by subtracting 2x here, then when you look into the mirror, you must also be, of course, bobbing your hair. So if you have 2x and then you subtract 2x from this, you must do the same thing here. Long and short of the story is that if you have a case like this, when you bring it across the inequality or equality as the case may be, the sign in front of it will change. That's what I'm trying to say. When you bring it across the inequality, the sign in front of it will change. The sign here is plus. When you bring it across the inequality, it becomes minus 2x, which looks as if I have subtracted 2x from both sides. Remember the analogy of the mirror. 2x, suppose I decide to put minus 2x here. 2x minus 2x will give me 0, so this disappears. Now, I must do it to this side as well. Look at it here. Okay, so that's the idea. But we don't really go through this rigorous process of subtracting 2x from both sides. We just look at it in the sense that bring 2x across the inequality. The sign in front of it changes. Okay, that's just the basic idea. We have succeeded in bringing this here. So we have to also bring minus 6x across the inequality sign to join its pairs. Remember what we did earlier. When you bring minus 6x across the inequality, the sign in front of it will change so that it becomes plus 6x. Now we have succeeded in bringing all the terms with the variable x to the left-hand side of the inequality. What we'll do next is to move all the terms, all the constant terms to the right side. Less than or equal to. We already have minus 30 here on this side. We put it down, minus 30. If we observe closely, we would see that we have constant terms on this side of the inequality. So we need to push it to that side. The sign in front of 28 is plus. So when it moves across the inequality sign, it becomes minus, like I explained earlier. When it moves here, it becomes minus. So we have minus 30 minus 28. And here we have plus 4. When it moves across the inequality sign, it becomes minus 4. So we have succeeded in collecting all the like terms. Now, what's left is for us to simplify this. When I say simplify, we're going to write it in such a way that we have just one expression involving x. We're not going to have additions or subtractions. And we are going to achieve this by adding and subtracting. Eventually, we'll just have one single expression involving x. That's the goal. So how do we do this? This fraction will be a problem for us. Let's see if we can get rid of it. How can we get rid of it? We know that the denominator here is 3. What if we decide to multiply? Remember, whatever you do to one side of an inequality or an equation, you must always do to the other side. To get rid of this 3 here, it is clear that we have to multiply this by 3. 2 over 3. What will I multiply with 2 over 3 to get a whole number? It is 3. That's what I need to multiply with 2 over 3 to get the whole number. So that 3 will cancel 3. And then I would have 2, a whole number. So that at the back of my mind, I am going to multiply. I'm not just going to multiply this alone. Remember that this whole, everything here makes up this side of the inequality, not just this. So you can't just pick this out and do something to it and ignore the rest of them. It disturbs the balance of the value of your variable. It disturbs it. You can't just pick one term out of an expression and do something to it. You have to do it to every single term on that side. And not just only on this side, you have to also do it at the other side. And it affects every term on the other side as well. Okay? So, we have at the back of our mind that if I multiply this by 3, I'll be able to get rid of this 3. That's at the back of my mind. I would multiply this side of the inequality with 3. I would also do the same to this side. And you would see how the fraction disappears naturally. So I would say multiply both sides by 3. Okay, so this means 3 into 7x minus 2 over 3x minus 2x plus 6x, and close the bracket. This way, the 3 affects every single term in the bracket. Less than or equal to, the same must be done to the right-hand side of the inequality. Minus 30 minus 28. This can be simplified immediately, but we could still proceed this way. So now, plus times plus, plus 3 times 7x would give 21x. Plus times minus would give minus. 3 times 2 over 3x, we have already seen gives 2x. Because 3 would take care of this 3, you'll be left with just 2x. 3, okay, plus times minus, minus. 3 times 2x would give 6x. And then plus times plus would give plus. 3 times 6x would give 18x. So you see naturally how the fraction disappears. Let's simplify what's in this bracket here and then multiply straight on. Minus 30 minus 28 minus 4. What's the value of this? Let's look at it this way. Let's agree on the fact that the negative value represents a debt that you are owing. Okay? Let's agree on that. And of course, positive value represents the fact that you have money in your pocket. So this here means you are owing 30 naira. If you are owing 30 and you are owing 28 and you are owing 4, does this mean you have money or you are still owing? I want to think that if you are owing 3 times, then as long as you've not paid, you'll still be owing, right? So it means you are owing the sum of all these amounts. 30, 28, and 4. What does it mean? It means you are owing at 62. Now we have agreed that negative stands for a debt. So you should have that you are owing 62. Okay? So the value of this is minus 62. Now let's simplify this. We have agreed that positive means that you have money and negative means that you are owing. So here we have a positive sign, you have 21, x. Again, we have a positive sign here, you have 18. If you have 21 in your left pocket and you have 18 in your right pocket, how much do you have altogether? It means you have 39x, right? Now you're walking down the street and you come across a friend of yours whom you're owing. Remember, negative stands for a debt. You're owing 2x. And while in the midst of pleading to push your debt further, another friend comes. A friend you are owing 6x. Owing 6x. How much are you owing altogether? 2x. You are owing 6x as well. It means you are owing 8x, right? Now remember, you have 39x in your pocket. And of course, you become embarrassed by the, asking for debt. And then you decide, okay, I'm going to pay my debt. You bring out your 39x from your pocket. When you pay this debt, would you still be owing? Or would you have money with you? You're owing 8x. You have 39x. When you pay this debt, I want to think that you would still have money with you. You would have 31x. That's what I think you would have. 39x minus 8x. Let's put it this way. It means you have 39x minus 8x. Less than or equal to. Now we can expand this. Plus times minus still remains minus, it never changes. And then 3 times 62 will give 186. 186. 39x minus 8x would give 31x less than or equal to minus 186. So now how do we find x? We're almost at the end of the problem. We can see the promised land. Remember, I told you that the goal here was to simplify this to a single expression involving x, which we have done. Now, how do we find x? We ask ourselves, what is the operation joining 31 and x? Operation, our basic operations are addition, subtraction, multiplication, and of course, division. In mathematical jargon, 31x means 31 times x. So it means the operation joining 31 and x together is multiplication. Now, to get rid of 31, in order to find x must stand alone on one side of the inequality. That's the only way you're going to find x. It mustn't be attached, nothing must be attached to it. Okay? So, in order for us to find x, it means x must be alone on this side of the inequality, which means 31 must leave. Now, how does it leave? You don't just throw it away. You don't just throw it away. How does it go? You ask yourself, what's the operation combining 31 and x? The operation is multiplication. We usually regard division as the reverse of multiplication. So that in order for 31 to go, you must ask yourself, what will I divide 31x by to give me x? It's a simple question. What will I divide 31x? 31x over what will give me x? That's the question. 31x. The question is 31x over what will give me x? That's our question. I want to think that this is obvious. I think our question mark should be replaced with 31, so that 31 taking care of 31 would leave you with just x. Okay, I hope this is clear enough. Let's do it again. The operation joining 31 and x is multiplication. Because the operation is multiplication, we make use of the reverse of multiplication, the opposite of it, which is division. And then ask, what do we need to divide this by to get just x? Because that's your goal, to have x alone on one side of the equation. And that's why we have been shrinking all these long things to eventually get here, so that we can have just x alone. We have agreed here that it is 31. Now remember that you cannot barb your hair here and not barb it here. Okay? So if you have decided to divide the left side of the inequality by 31, you must also do the same for the right side. So that we divide this by 31. And we would have x to be minus 6. X less than or equal to minus 6. What this means is that the values of x that will satisfy this inequality will always be smaller or equal to 6. That's what it says. Inequalities can always be represented on number lines. A number line. This is 0. A number line is a pictorial representation of numbers on a line. What this answer is telling you is that if you have your minus 6 somewhere here, minus 5, minus 4, minus 3 until you get to 0, the values that will satisfy this inequality can never exceed this place. So the only values that will satisfy this inequality are the values to this side of your number line. That's what it's telling you. So this brings us to the end of the solution for this problem. I hope that I have been very clear enough. I'd like to think that the procedures to providing the solution to this problem was as clear as possible. I think this is a good point to end this lesson. And in the next lesson, we would consider another standard question that you would most likely come across in any O-level external examination. Thank you.